Hello, my cherished viewers out there. I welcome you once again to yet another lesson on my YouTube channel, Rediscover Your Touch. And we'll actually be talking about Circle Theorem 4. And prior to that, I'll urge you guys to do it a big deal to subscribe to my YouTube channel and also to like this video and do well to share this knowledge to your colleagues who might really be in need of it. So I trust we can commence now. Over here, we are having our second theorem 4, which proceeds that angles that a chord or an arc subtends at the circumference of opposite segments of a particular circle are supplementary. That is, they sum up to give 180 degrees. And I quote again, angles that a chord or an arc subtends at the circumference of opposite segments of a particular circle are supplementary, and that really implies that they sum up to give 180 degrees. Alright, so per the illustration on the board, we have our chord PR. Our chord PR. We also have our segment, that is our major segment, PQR. Our major segment, that is the upper portion, as PQR. We also have our minor segment, PSR. And we also know that angle PQR is B degrees. Angle PQR is B degrees. And also angle PSR is A degrees. Angle PSR is A degrees. And for that matter, per our deliberations or per what the theorem proceeds, we are actually going to sum the opposite angles as in respect to angle B to angle A. And in that sense, they should really sum up to give us 180. So obeying our theorem 4, we are actually going to have our deliberations to sum up to 180. So per the illustration on the board, we are actually going to have angle PSR. That is angle PSR plus angle PQR is equal to 180 degrees. Angle PSR and angle PQR sum to give us 180 degrees. We could also have, in place of angle PSR, that is PSR, that is what? A degrees, right? So our angle PSR translates to give us A degrees. And also our angle PQR also give us B degrees. B degrees, which should also be equal to 180 degrees, which should also be equal to 180 degrees. So either we are dealing with the three-dimensional alphabetical representation of angles, or we are actually representing the angles with variables. We are likely going to have our answer to be in this aspect, or our relation or our equation to be in this aspect, either with the three-dimensional alphabetical representation of our respective opposite angles within the circumference of the circle, or having our variables to represent the opposite angles in our circumference of the circle. So this is actually what really entails about our theorem 4 for circle theorem or plane geometry 2. And for that fact, we'll actually be looking at a respective example to actually have an insight about which we are really meaning on aspect of having our theorem to be as such. So we could really move on using our respective theorem to answer the example here. So I trust I could plane this equation. So we have our angle ABC as 116 degrees. 116 degrees. We also have angle ADC as our K degrees. So per our theorem 4, which says that angles that a chord or an arc subtend at the circumference of opposite segments of a particular circle are supplementary. That means you should really add them up to give you 180 degrees. So our chord AC possesses an angle at both the major segment ADC and minor segment ABC, and giving us angles at the opposite sides of the circumference or of the chord AC. So our solution for this example is going to be our angle ADC, which is the same as K degrees, plus our angle ABC, which is also 116 degrees. So I could say angle angle ABC is equal to 180 degrees. Must be equal to 180 degrees. So we have K degrees plus 116 degrees is equal to 180 degrees. So we make K the subject, and then we have 180 degrees minus 116 degrees. 180 degrees minus 116 degrees. So we have our usual subtraction. So 180 minus 116. So we transfer, so we have 7 here, 10 here. So 10 minus 6, 4, 1 minus 7, 6, and 1 minus 1, 0. So we have our angle to be 64 degrees. So therefore our K is 64 degrees. So if I really want to illustrate it within the diagram, then I would have K to be 64 degrees. 64 degrees. So this is how well we can apply circle theorem 4 in aspect of making our deliberations on some respective questions. And I trust you really get the knowledge that we've actually discussed thus far. So without wasting my time, I'll be drawing curtains on our today's lesson, and then I'll do my best to cover other theorems as well. If possibly, we could move on with further examples concerning theorem 4 if I deem it fit. And for that matter, we'll actually be drawing curtains like I speculated, and I'll urge you guys to do it a decision to subscribe to my YouTube channel, to like my video as well, and also to do well to share this video among your friends, among your colleagues who might be in need of this knowledge. So for that matter, I would say once again your tutor, Ebenezer Kobe, and we call it a day. Bye.